Hi guys, now we are going to see the one important concept in vector space, that is linear isomorphism or isomorphism. A linear transformation T from U to phi is called a isomorphism or a linear isomorphism, or is called invertible if T is 1 1 and onto. That is, T is called isomorphism. A transformation T from U to phi is called isomorphism if T is linear, first one, T is 1 1 and T is onto. Consider an example T from R2 to R2 defined by T of xy is equal to x plus y comma 2x minus 3y. xy belongs to R2. Then we have already seen that such type of a transformation are linear in both the components, in its first component and in its second component. So this is linear from R2 to R2. So clearly T is a linear transformation. We have to check whether this linear transformation is isomorphism or not. For that we have to check whether T is 1 1 or not. First one, T is 1 1. For that we have already proved a theorem that T is 1 1 if and only if kernel of T is equal to 0. That's why we have to calculate this kernel of T. If this kernel of T is 0, then this is a 1 1 linear transformation. So kernel of T is equal to, what is the definition of kernel of T? Kernel of T is equal to all vectors U is equal to xy in R2 such that whose image is a 0 vector. So xy belongs to equal to 0, xy belongs to R2 such that T of xy equal to 0, 0 means what? T of xy is x plus y equal to 0 and 2x minus 3y equal to 0. This is equal to all xy belongs to R2 such that x plus y equal to 0, x minus y equal to 0 means what? When you solve this type of equations, x plus y equal to 0, 2x minus 3y equal to 0, what you get? Put x is equal to, this implies that x equal to minus y in this equation. What you get? 2 into x equal to minus y or minus y equal to x. 2x plus 3x equal to 0. This implies that x equal to 0. If x equal to 0, then y equal to 0. So we get all ordered pair xy belongs to R2 for which x equal to 0 and y equal to 0. That is, x and y are 0 0. This is the 0 vector in R2. So therefore T is 1 1. Now we have to check whether this T is onto or not. For that, if when T is onto, if the image set or range of T is whole vector space R2. So consider range of T is equal to, by definition this is just T of xy belongs to R2. T of xy is defined as x plus y comma 2x minus 3y. xy belongs to xy, ordered pair xy belongs to R2 means what? The element x and y belongs to R. So this can be written as sum of two ordered pairs. So this is x plus y comma 2x minus 3y. This can be written as this by definition of sum of two ordered pairs. xy belongs to R. So this can be written as 1 comma 2 into x plus 1 comma minus 3 into y. xy belongs to R. This is just when you recall the definition of a linear span or linear combination of vectors. This is just the span of 1 comma 2 comma 1 comma 3, and it can be easily checked that the vectors 1 comma 2 and 1 comma minus 3 are linearly independent. So if these are linearly independent, then the space spanned by these two vectors is nothing but the whole vector space R2. So this image of T is whole R2, therefore T is onto. Therefore this T is onto. Therefore this T is onto. From 1, 2 and 3, what you get? T is linear transformation, T is 1 1 and T is onto. So T is a linear transformation. Thus T is a linear isomorphism. Or T is an invertible map. T is invertible. Thank you, students.